Welcome to Study Loop.
This is the answer to Chapter 24, problem number 53 from the Smith Organic Chemistry textbook. This problem says, in theory, the intramolecular aldol reaction of 6-oxoheptanal could yield 3 compounds. However, only one acetylcyclopentene is the major product. Why are the other two formed in only minor amounts? And we're asked to draw a stepwise mechanism to show how all 3 products are formed. Okay, so really, unfortunately, here we're drawing 3 stepwise mechanisms. So I'm going to get through this as quickly as possible. So first, the first mechanism I'm drawing here shows the formation of the major product. So that is going to go like this. So deprotonation at this alpha carbon, deprotonation of that alpha proton gives us this enolate. Okay, so lone pair and a negative charge here. This is a pretty stable enolate. It's internal to the molecule, and it is able to attack an aldehyde, which is less hindered than a ketone. And so that is why this is the most favored pathway for this reaction to proceed through. So after that attack, we form a 5-membered ring. There's our 5-membered ring. Okay. All right. So this needs to now be protonated, which water can do. So grab that proton from water. Okay. And now the next thing that's going to happen, so there's a proton here. That is going to be grabbed by another hydroxide ion. These electrons will go here. And the hydroxy group will take off. Oh, you know what? I guess we can't draw that as a single step, actually. So I apologize. So these electrons will go here. Okay, so lone pair negative charge here. Now they'll add in here, and the hydroxy group will leave. And so that gets us to our final product. And again, this is the major product here. This is the mechanism by which that major product forms. And again, it is the major product, and I'll write that over here. So this is the most stable enolate. And it is attacking the less hindered carbonyl, which would be the aldehyde. So attacking less hindered carbonyl. So this is the most stable enolate attacking the less of the 2 carbonyls, the less hindered of the 2 carbonyls. So that's what makes this so favorable. So when we look at the other 2 pathways by which this mechanism would have to proceed to yield the minor products, they are going to look like this. So to yield one product, we would deprotonate here. at the alpha carbon to the aldehyde. And so that is going to give us this. So we would have our enolate here now. And this is a stable enolate, but it now has to attack the more hindered ketone, which is going to be unfavorable. But so this is how this pathway would proceed. So again, 5-membered ring formation here. And then the rest of this mechanism looks a lot like the first part, the first page. So protonation. Followed by deprotonation. Draw this here. So followed by deprotonation by hydroxide. So grabbing this proton, these electrons going to the carbon there. So again, lone pair and negative charge on this carbon. These can now add in. The hydroxide will leave. And so we get this minor product. Okay, and again, this is a minor product because although this is a stable enolate, it is attack on a ketone, which is by definition more hindered than an aldehyde. So attack on hindered carbonyl. So that's what makes this pathway less favorable. And then the third pathway that we have to look at would be deprotonating this alpha carbon of the ketone, but it is the terminal alpha carbon. And so we get a less stable enolate just because it is a terminal enolate. So let's take a look at what that would look like. Okay, so there's our enolate. Something else to keep in mind, it's now fairly far away from this aldehyde that it has to attack, but so it could attack the aldehyde. Which the other thing, I guess, which is related to it being far away, is instead of forming a 5-membered ring, which is favorable, we are now forming a 7-membered ring, which, in addition to being difficult to draw, is unfavorable. Okay, so there we go, 7-membered ring. Our ketone would be here, and we would have this. Let me move this down a little. Okay. All right. And so once again, from here, this mechanism is going to look just like the other two. So protonation. and then that is going to be followed by deprotonation here at the alpha carbon. Oops. By hydroxide. And then that will be followed by these electrons adding in to form a new double bond and the hydroxide taking off. And so that gets us to our third possible product here. Once again, it's a minor product. Okay. And so this one is a minor product because it forms from the less stable enolate, and because it forms a 7-membered ring. So those two things are more than enough to make it unfavorable. So that's why this one is unfavorable. The other minor product is unfavorable because of the attack on the ketone, which is the more hindered carbonyl. And the major product is favorable because it forms from the most stable enolate, and it forms from attacking the less hindered of the two carbonyls. And that is the answer to chapter 24, problem number 53.